Hello everyone, I am Balaji Rao. Welcome to BR Max class. Till now, what we learned in this continuity chapter? We learned what is continuous function, how to check the function is continuous function, how to find points of discontinuity of given function. And we learned how to find the value of k when given function is continuous at an indicated point. And we learned how to find the values of a and b when the given function is continuous function. In this class, what are the things we are going to learn? You observe this one. In this class, we will do three problems. You observe this question number 21. Determine this function is continuous function. Is this function is continuous function? We need to determine that. Okay. Next, question number 25. You observe. Examine the continuity of the function. We need to check whether this is continuous or is there any point of discontinuity, that we need to check. Next question. You observe this question number 23. See, I am doing all the problems model wise. So these three problems 23, 24, 25 comes under one model. You observe, find all points of discontinuity of f. We need to find all points of discontinuity of f for the given function. These three problems we are going to do in this class. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. Okay, now you observe this question number 24. Determine the function. The function is defined like this. This is the function. Is a continuous function? They are questioning us. Is this function is a continuous function? So I need to check continuity of this function. Continuity is always meaningful to discuss in the domain of the function. Now my question is, what is domain of this function? Is this function is defined for all real numbers? Is this function is defined for all real numbers? I'll check. Suppose x equal to 100. Then which function to choose? 100 is not equal to 0. So I'll choose the first function. Okay. X equal to -3. Then which function to choose? -3. -3 is not equal to 0. Then I'll choose this function. Whenever x value is non-zero number, in that case we will choose this first function. Okay. When x equal to 0, at that time what function to choose? When x equal to 0, at that time I'll choose second function. Suppose x equal to -1/2 is there. And then which function to choose? -1/2, which is non-zero number. Then I'll choose this first function only. My question is, what is the domain of this function? Domain of this function is all real numbers. So I need to check the continuity of the function on its entire real numbers. Okay. So I came to know that the domain of the given function is all real numbers. You can observe here x equal to 0, x not equal to 0, x equal to 0, two things are given. So I divide this problem into two cases. That is important. I do this problem. See, till now we did 3 case problems, 5 cases problems, 7 cases problems also I did. Now this is 2 case problem. Look here. What are those 2 cases? Okay. X equal to 0 they given. Here 0 I'll write. Case 1 is when x value is not equal to 0. I'll do this problem in 2 cases. Case 1, what is that case 1? When x value is not equal to 0. Okay. Case 2, I'll check the continuity at x equal to 0. This is case 3. Okay. Case 1, case 2, sorry. We are going to do this problem in 2 cases only. Na? When x is not equal to 0, that is case 1. Okay. When x equal to 0, that is case 2. I am going to do this problem in 2 cases. Okay. Let's start the solution. Okay. Case 1. I am checking the continuity of the function at x equal to a. What is a here? A is non-zero real number. That means I am checking continuity in this zone as well as in this zone. What a value I can take here? A, you can take any negative real number. A, you can take any positive real number. I am checking the continuity in this zone as well as in this zone. Okay. Now hero of this story. When we say a function is continuous at x equal to a, limit x tends to a, f of x equal to f of a. Then we say that the function is continuous at x equal to a. So to check the continuity at x equal to a, I need to check this one. So what I'll do, I'll calculate this one first. Next, I'll calculate this one. If both are equal, then I can say that this function is continuous at x equal to a when a is non-zero real number. Okay. So first I'm going to calculate this one. Limit x tends to a, f of x. Okay. Limit x tends to a. Limit x tends to a, f of x. Okay. That equal to limit x tends to a. What is the function? X approaches to a. What is a here? A is non-zero number. When a is non-zero number, in that case, what function to choose? This function. What is this? X square into sine 1 by x. Okay. F of x is x square into sine 1 by x. Okay. Now, I need to calculate this limit. How to calculate this limit? Direct method. What is direct method? In the given function, wherever x is there I'll write a. You write a. Okay. X square will become a square into sine. Wherever x is there you write a. So, x square into sine 1 by x. In place of x, if you write a, then you will get this. So, I calculated this one. I got a square into sine 1 by a. Here a value is what? A value is non-zero real number. Okay. Now, I will calculate f of a. To calculate f of a, you need to decide which function to choose here. Which function to choose? F of x is what? F of x is what? Which function to choose? Here I want to calculate f of a. What is a? A is a non-zero number. When a is non-zero number, what is the function? X square into sine 1 by x. So in this case, to calculate f of a, f of x is x square into sine 1 by x. So what is f of a? F of a is a square into sine 1 by a. Right? So what is f of a? F of a is a square into sine 1 by a. You look here, I calculated this one, I got 1 minute. I calculated this one, I got a square into sine 1 by a. I calculated f of a, that is also I got a square into sine 1 by a. So these two are equal. These two are equal. So what I can say? I can say that this condition holds good. So I'll write therefore limit x tends to a, f of x equal to f of a whenever a is not equal to 0. From this, what I can write? I can write like this. Therefore, f of x is continuous at x equal to a is not equal to 0. So, I checked the continuity in case 1. Whenever a is non-zero number, I checked the continuity. What I got? I got that this is continuous at x equal to a whenever a is not equal to 0. What they are asking? They are asking, is this function is continuous function? What I got? I checked in case 1. I got that it is continuous at every real number except 0. Now, I need to check at 0. Then I can say it is continuous function or a discontinuous function. Now, I'll check the continuity at x equal to 0. That is case 2. Okay. I'll take this function along with us. What I am checking now? Case 2. What is case 2? At x equal to a equal to 0. Okay. I am checking the continuity of the function at x equal to 0. When we say function is continuous at x equal to 0, from the beginning of this chapter we are discussing this point. I am tired, whether you tired or not. When we say function is continuous at x equal to 0, yes. When we say function is continuous at x equal to 0, answer limit x tends to 0, f of x equal to f of 0. Limit x tends to 0, f of x equal to f of 0, then we say that function is continuous at x equal to 0. So, to check the continuity at x equal to 0, I need to check this condition. So, what I will do now? First, I will calculate this one. Next, I will calculate f of 0. If both are equal, then I can say that function is continuous at x equal to 0. Okay. First, I will calculate this one. Right. Limit x approaches to 0, f of x. Okay. That equal to limit x approaches to 0. X approaches to 0 means what? All x values are slightly less than 0 or slightly greater than 0 but not 0. Correct? All x values are slightly less than 0 or slightly greater than 0 but not 0. That means x approaches to 0 means x is not equal to 0. X approaches to 0 means x not equal to 0. X values are slightly less than 0 or x values are slightly greater than 0. When x is not equal to 0, in that case, we need to choose the first function. Here, what is f of x? F of x is first function x square into sine 1 by x. So, f of x is x square into sine 1 by x. Okay. Now I want to calculate this limit. How we will calculate this limit? By direct method. What is direct method? In this function, wherever x is there we will write 0. Here small problem is there. X approaches to 0 means x is not 0, but x is very nearer to 0, slightly less than 0. So, when I try in direct method, listen here. When I try in direct method, in place of x, if I write 0, 0 square is 0 into, you look here, sine 1 by x. Sine 1 by x. What is x? X is, you look here, 1 by x. If you write in place of x, if you write 0, you may feel that sine 1 by 0. 1 by 0 is not defined. So, sine 1 by 0 is not defined. You may think like that. X approaches to 0 means x values are slightly less than 0 or x values are slightly greater than 0 but not 0. So, here the point is x value is not 0 but very nearer to 0. You know that sine function range is closed interval minus 1 comma 1. So, whatever x value I take here other than 0, very nearer to 0, sine 1 by x value always in between closed interval minus 1 comma 1. So, what I am trying to say, when x approaches to 0, then this is a finite quantity. You don't think that it is not defined. Okay. So, what I will write here, it's a finite quantity. Finite quantity means it is a value in between minus 1 and plus 1. It's a finite quantity. 0 into finite quantity is what? 0. This is a little confusing part in this. That's it. Okay. What happened here? 0 into finite quantity is 0. I calculated this one. I got it as 0. Now what to calculate? I need to calculate f of 0. Okay. F of 0 I want to calculate. F of x, f of 0. F of x, f of 0. In place of x, here 0 is there. In the question only directly given, when x equal to 0, function is 0. When x equal to 0, f of x is 0. So what is f of 0? F of 0 is 0 only. Directly they given. So f of 0 is 0. What happened? I calculated this one. I got 0. I calculated f of 0. I got 0. So what I can say? I can say that these two are equal or not? Yes, these two are equal. So therefore, what I got here? I got that therefore limit extends to 0. F of x equal to f of 0. From this what I can say? I can say that f of x is continuous at x equal to 0. Therefore, f of x is continuous. F of x is continuous at x equal to 0. X equal to a is 0 in this case. Okay. I checked the continuity in case 1. What I got? I got it is continuous. Now, I checked the continuity at a equal to 0. What I got? I got it is continuous at x equal to 0. So, case 1, it is continuous when a is not equal to 0. Case 2, when a equal to 0, it is continuous. So, what they are asking in the question is this function is continuous function? Yes, this function is continuous function. So, what I can write here? Therefore, from case 1, comma, case 2, what we can conclude? We can conclude that f of x is continuous function. F of x is continuous. F of x is continuous function. So, I hope you understand this problem. That's great. Now, we'll move to next question. You observe this question number 25. Examine the continuity of the function. Examine the continuity of the function where the function is defined like this. Okay. Now this problem, last problem are similar. Now my question is to examine the continuity of the function, you need to know domain of this function. What is domain of this function? Yes. Can you answer what is the domain of this function? Domain of this function is all real numbers. For example, you take x equal to 2. 2 is not equal to 0. In that case, we will choose the first function. X equal to minus 1. When x equal to minus 1 is a non-zero number. In that case, we will choose the first function. When x equal to 0, in that case, directly they given, we need to choose the second function. So, what I am trying to say, the domain of this function is what? Yes, answer. Domain of this function is all real numbers. So, again, I am going to do this problem in two cases. Like last problem. Please observe this one. I am going to do this problem in two cases. What is case 1? At x equal to a is non-zero number. This is the case 1. I'll check the continuity of the function in case 1 like this. Okay. Next, I'll check the continuity of the function at 0. So, in two cases, I'm going to do this problem. Let's start this solution. Okay. First case, at x equal to a, what is a? A is at x equal to a is not equal to 0. I am checking the continuity of the function at x equal to a is not equal to 0. A is not equal to 0 means where I am checking continuity. You can check continuity at negative real, at any negative real number. Here a may be minus 4, a may be minus 4, a may be minus 3, a may be minus 100, a may be plus 3, plus 4, plus 100, plus 1000, like anything. I am checking the continuity in this zone. Okay. How to check the continuity of the function? Hero of the story. What is that hero of the story? Limit x approaches to a, f of x equal to f of a. Then we say that this function is continuous at x equal to a. If this holds good, then we say that this function is continuous at x equal to a. So what I'll do, I'll calculate this one first. Next I'll calculate this one. If both are equal, then I can say that this function is continuous at x equal to a. Okay. So I'll calculate this one. Okay. Limit x approaches to a, f of x. X approaches to a, f of x. Here x approaches to a. What is a? A is a non-zero number. When a is a non-zero number, which function to choose? This first function, sin x minus cos x. So in place of f of x, I'll write sin x minus cos x. Okay. Limit x approaches to a. In place of f of x, what we'll write? We'll write sin x minus cos x. Okay. Now observe this one. I need to calculate this. How we will calculate this? We will do this by direct method. What is direct method? In the given function, wherever x is there we will write a. What is a here? A is a non-zero real number. Okay. So, in the given function, wherever x is there you write a. What it will become? It will become sin a minus cos a. Okay. So, I calculated this one. I got it as a sin a minus cos a. Okay. Now, I will calculate this f of a. F of a. To calculate f of a, you need to know what is f of x here. You need to know what is f of x here. What you are trying to calculate? You are trying to calculate f of a. To calculate f of a, which function to choose? Here, what is a? A is non-zero number. When a is non-zero number, which function to choose? We need to choose sin x minus cos x. So, f of x is sin x minus cos x. What is f of a? F of a is what? F of a is sin a minus cos a. So what I'll do, I'll write f of a. What is f of a? F of a is sin a minus cos a. So what happened here? I calculated limit extends to a, f of x. I got sin a minus cos a. I calculated f of a, that is also sin a minus cos a. So what I can say here? I can say that these two are equal. Equal or not? Yes, equal. Therefore, limit extends to a, f of x equal to f of a. Therefore, limit extends to f of x equal to f of a. Then from this, what I can say? F of x is continuous. F of x is continuous at x equal to a. Here, in this case, a is a non-zero real number. So, I checked the continuity in case 1. I got that it is continuous at x equal to a whenever a is non-zero real number. Now, I need to check the continuity at x equal to 0. Case 2. I need to check the continuity of the function at x equal to 0. Okay. This is case 1. Now case 2. Case 2. Okay. This is case 1. Case 1. Okay. Case 2. At x equal to a. What is a? A equal to 0. I am checking the continuity at x equal to 0. Okay. Now I am checking the continuity at x equal to 0. When we say the function is continuous at x equal to 0, when we say the function is continuous at x equal to 0, we know this. Limit x approaches to 0, f of x equal to f of 0. Then we say that this function is continuous at x equal to 0. So to check the continuity at x equal to 0, I need to check this condition. So what I will do, I will calculate this one. Next, I will calculate this one. If both are equal, then I will say that this function is continuous at x equal to 0. Okay. First, calculate this one. Limit x approaches to 0, f of x. x approaches to 0. X approaches to 0 means what? All x values are slightly less than 0 or all x values are slightly greater than 0 but not 0. Correct? So what I'll write here, limit x approaches to 0. X approaches to 0 means all x values are slightly less than 0 or all x values are slightly greater than 0 but not 0. So x approaches to 0 means x is not equal to 0. When x is not equal to 0, what function to choose? The sin x minus cos x. So in place of f of x, what I'll write here? Sin x minus cos x. So you write here sin x minus cos x. Okay. Now I need to calculate this limit, right? I need to calculate this limit. How we will calculate this limit? By direct method. What is direct method? This is the function. In the given function, wherever x is there you write 0. Okay. That equal to, in place of x, you write 0. What you will get? Sin 0. 1 minute. Sin 0 minus cos 0. Trigonometry table. You know sin 0 value is 0, cos 0 value is 1. So that equal to 0 minus 1. That equal to minus 1. So when I calculated limit extends to 0 f of x, I got minus 1. Okay. Now I will calculate this f of 0. I will calculate f of 0. Okay. To calculate f of 0, you need to know what function to choose. F of x, f of 0. F of x, f of 0. In place of x, 0 is there. That means x is 0. When x is 0, what is the function? Directly given in the question. When x is 0, we need to choose the function minus 1. So f of 0 is what? Directly they given that f of 0 is minus 1. You observe here, this value is minus 1. This value is also minus 1. So what I can say? I can say that these two values are equal. So I'll write the same thing. Therefore, limit extends to 0, f of x equal to f of 0. As this holds good, what I can say? As this holds good, I can say that this function is continuous at x equal to 0. I'll write the same thing. Therefore, f of x is continuous. F of x is continuous at x equal to a. Here a value is 0. I checked the continuity at 0. What I got? I got that it is continuous at 0. So in case 1 also, you observe in case 1 also, whenever a is non-zero number, non-zero real number, I got it is continuous, and here also it is continuous. So what I can say? What they are asking? Examine the continuity of the function. I checked the continuity in its domain. In both the cases, I got it is continuous. So I can say that this function is continuous. This function is continuous function. Therefore, from case 1, case 2, what you can conclude? We can say that f of x is a continuous function. F of x is a continuous function. Okay, right. I hope you understand this second problem. Understand or not? Last problem for this class. You observe, find all points of discontinuity of the function. We need to find all points of discontinuity of the function, and the function is like this. And you observe, what is the domain of this function? Domain of this function is this function defined for all real numbers. Suppose x equal to 100. Which function to choose? Here 100 is greater than 0. Now, when greater than 0 is there, then we will choose the second function x plus 1. Suppose x equal to minus 2. When x equal to minus 2, minus 2 is less than 0. Now, in that case, we will choose the first function. Suppose x equal to 3 by 2. 3 by 2 is greater than 0. Now, when it is greater than 0, we will choose the second function. Now, you can easily understand that the domain of this function is all real numbers. Correct or not? Okay. So, where I need to check domain of the function? To find all points of discontinuity, I observed the given function. It can be understood easily that the domain of the function is all real numbers. So, I do this problem in 3 cases. What are those 3 cases? First, you can observe given function is varying at x equal to 0. What is case 1? Case 1, I will check the continuity whenever a value is less than 0. I'll take this as case 1. Next, I'll check the continuity at 0. This is case 2. What is case 3? Whenever a value, x value is greater than 0, that is case 3. So I am going to check the continuity of this function in 3 cases. This is case 1, this is case 2, and this is case 3. Okay, let's start the solution. Solution. Okay, case 1. Okay, what is case 1? At x equal to a is what here? A is less than 0. I am checking the continuity at this point. When we say function is continuous at x equal to a, hero of the story. Limit x approaches to a, f of x equal to f of a. See, in this exercise there is no other formula except this. Limit x tends to a, f of x equal to f of a. So what I'll do, I'll calculate this one and then I'll calculate this one. If both are equal, then I can say that this function is continuous at x equal to a. Okay, so I'm going to calculate this one. Limit x tends to a, f of x. Okay, limit x approaches to a, f of x. Okay, that equal to limit x approaches to a. Here x approaches to a value is less than 0. When a value is less than 0, which function to choose? We'll choose this function, sin x by x. So what I'll do, in place of f of x, I'll write sin x by x. So in place of f of x, you write sin x divided by x. Now, now listen, how to calculate this one? How to calculate this one? Direct method. What is direct method? Wherever x is there in the given function, wherever x is there, there you write a. So what you will get, this is sin a divided by a. What is a here? A may be any negative real number. It may be minus 100, it may be minus 3, it may be minus 1, it may be any negative real number, because this is the case that a is less than 0. So I calculated limit x tends to a, f of x. I got sin a by a. Now I'll calculate f of a. Okay, calculate f of a, that equal to calculate f of a, you need to know what is the function to choose here. Here f of a you are calculating a, f of x, f of a. In place of x, a is there. What is a here? A is less than 0. When a is less than 0, which function to choose? The function is sin x divided by x. Okay, what is f of a? In place of x, in the given function here, to calculate f of a, in this function sin x by x, wherever x is there, there you write a. So what you will get? This is sin a divided by a. So what is f of a? F of a is sin a divided by a. So I calculated this one, I got sin a divided by a. I calculated this one, this is also sin a divided by a. So I can say that limit x tends to a, f of x equal to f of a. This holds good. Therefore, limit x tends to a, f of x equal to f of a. From this, what you can say? Therefore, you can say that f of x is continuous. F of x is continuous at x equal to a. What is a here? In this case, a is less than 0. In this case, a is less than 0. Okay, I checked the continuity of the given function in this zone. I got that it is continuous. Now, case 2. I'll check the continuity at x equal to 0. Okay, case 2. Case 2. What is case 2? What is case 2? I am checking the continuity of the function at x equal to a equal to 0. I am checking the continuity function at x equal to 0. When we say function is continuous at x equal to 0, you know this. Limit x approaches to 0, f of x equal to f of 0. Limit x tends to 0, f of x equal to f of 0, then we say that function is continuous at x equal to 0. So what I'll do, I'll calculate this one and then I'll calculate this one. If both are equal, then I say that function is continuous at x equal to 0. So first I want to calculate this one. To calculate this one, we have a problem. You observe here, x approaches to 0. X approaches to 0 means x values are slightly less than 0 or x values are slightly greater than 0 but not 0, right? So here x approaches to 0 means x values are slightly less than 0. When x values are less than 0, then we need to choose this function. X approaches to 0 means there is a chance that x values are slightly greater than 0. When x values are greater than 0, then we need to choose this function. So to calculate limit x tends to 0, f of x, which function to choose? We have a confusion. To avoid this confusion, best thing is you calculate left hand limit, right hand limit. Okay, left hand limit I will calculate. At x equal to 0, I am calculating left hand limit. How to calculate? Limit x approaches to 0 from left, f of x. X approaches to 0 from left. It means that all x values are slightly less than 0. Okay, when x values are less than 0, we need to choose this function. What is the function? Sin x by x. Limit x approaches to 0, sin x divided by x. Here again you may confuse. Chances are there you may confuse here. In limits chapter, in class 11 limits chapter, we have a result. What is the result? Limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, sin x divided by x equal to 1. You know this result. When this holds good, when this limit exists, this value is 1. It means that left hand limit at x equal to 0 exists, right hand limit at x equal to 0 exists, and both are equal to 1. Then only we say that limit x tends to 0, sin x by x value is 1. So as we know this result, we proved this result, this theorem we learned. So I can directly write from that theorem this value is 1. You do not go here by direct method. You don't write sin 0 by 0, an indeterminate form you will get. This is the theorem, this formula we derived in limits chapter. Okay, right. So left hand limit I calculated, I got 1. Now I'll calculate right hand limit. How to calculate right hand limit? Limit x approaches to 0 from right, f of x, that equal to limit x approaches to 0 from right. X approaches to 0 from right means all x values are greater than 0. When x values are greater than 0, we need to choose this function f of x as x plus 1. So in place of f of x, I'll write x plus 1. Now I need to calculate this limit. How to calculate this limit? In the given function where x is there you write 0. So what you will get, that is 0 plus 1. 0 plus 1 is 1 only. You observe here, I am trying to calculate this. I decided to calculate this. I want to calculate left hand limit as well as right hand limit. So here left hand limit what I got? 1. Right hand limit I got 1. Left hand limit equal to right hand limit. So what I can say? I can say that left hand limit is same as right hand limit. When left hand limit is same as right hand limit, then we say that limit of the function exists. So therefore limit x approaches to 0 f of x. What is its value? What you got here? Its value is 1. So this is 1. F of x is 1. This is 1. Okay. I calculated this one. I got 1. Now I'll calculate f of 0. I'll calculate f of 0. Okay. F of 0. To calculate f of 0, what function to choose? That is important. To calculate f of 0, what function to choose? F of x, f of 0. In place of x, here 0 is there. That means x equal to 0. When x equal to 0, you observe here, we need to choose this function, second function. Okay. So in place, f of x is what here? F of x is x plus 1. So in place of x, you write 0. What you will get? That equal to 0 plus 1. That is 1. Okay. So what is f of 0? F of 0 is 1. So I calculated this one. It is 1. I calculated f of 0. That is also 1. So what I can say here? I am checking in case 2 na, I can write this one. Therefore limit x tends to 0, f of x equal to f of 0. Therefore f of x is continuous at x equal to a equal to 0. I checked the continuity of the function in case 2 at 0. I got that it is continuous. So in case 1 also it is continuous. In case 2 also it is continuous. Now case 3 is remaining. I'll check the continuity of the function in case 3. Okay. What is case 3? At x equal to a. What is a? What is case 3? Case 3 is this case. This is the case 3. A value is greater than 0. So I am checking the continuity of the function at x equal to a is greater than 0. When we say function is continuous at x equal to a, limit x tends to a, f of x equal to f of a. Then we say that function is continuous at x equal to a. So I am going to check this. For that, I will calculate this one. Limit x approaches to a, f of x. Okay, that equal to limit x approaches to a. What is the function here? X approaches to a is greater than 0. When a is greater than 0, we will choose this function. So in place of f of x, I will write x plus 1. Okay, in place of f of x, you write x plus 1. Now you need to calculate this. How? By direct method. What is the direct method? This is the given function. In this given function where x is there you write a. So what you will get? That equal to a plus 1. I hope you understand this. Okay. Now I will calculate f of a. F of a. What is a here? What is a? A is greater than 0. When a is greater than 0, f of x is x plus 1. When a is greater than 0, f of x is x plus 1. When f of x is x plus 1, what is f of a? F of a is a plus 1. So what is f of a here? F of a is a plus 1. So I calculated this, I got a plus 1. I calculated f of a, I got a plus 1. So what I can say? Therefore, this limit x tends to a, f of x equal to f of a. Therefore, from this I can say that f of x is continuous at x equal to a. Here a is greater than 0. So case 1 it is continuous. Case 1 it is continuous. Case 2 it is continuous. Case 3 it is continuous. Actually what they are asking in the question, find points of discontinuity. Find all points of discontinuity. But in case 1 it is continuous. In case 2 it is continuous. In case 3 it is continuous. That means what I can write? Therefore, from case 1, comma, case 2 and case 3, what I can say? I can say that f of x is continuous function. Continuous function means there is no point of discontinuity. F of x is continuous function. There is no point of discontinuity. I hope you understand all the problems what we done today. In next class, we are going to discuss the continuity of the trigonometric functions. Discuss the continuity of sin x, discuss the continuity of cos x, and discuss the continuity of algebraic functions like greatest integer function, fractional part function. All those things we are going to discuss in next class.